is our infant universe. Everything that will ever exist, everything that will ever happen, all begins here, within this tiny bundle of energy, smaller than an atom. And right now, history as we know it is about to mysteriously begin. For reasons we may never know, our universe suddenly erupts.
In a millionth of 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 a second, it went from a size smaller than an atom to bigger than a galaxy.
Within a fraction of a second, the Big Bang creates all the energy that will ever exist. All the energy that will power the stars, that will fuel anything that ever lives. All the energy that you will ever consume dates back to the beginning of time. The first atoms blast through the early universe. And luckily for us, they don't spread out evenly. The first galaxies are beginning to form. 300 million years after the Big Bang. Inside of forming galaxies, gravity continues to squeeze together clouds of gas and dust, causing pressure and heat to violently rise. When the temperature reaches 18 million degrees Fahrenheit, hydrogen atoms slam together, creating a new element, helium, and radiating bursts of energy. The first stars are born.
Suddenly, there were these new beacons of light shining forth, pouring energy into the universe. Let there be light.
But something is missing from this early universe. There are billions of stars, yet not a single planet. To form planets, and eventually people, to take the next leap that would make all of history possible, the universe needs more to work with than just hydrogen and helium. Stars are element factories. They fuse hydrogen into helium, helium into lithium, forging 25 of the most common elements we'll need to live, including carbon, oxygen, nitrogen, and iron. So, more than 12 billion years ago, stars are already creating the element that will spur the Iron Age, allow for the building of cities, and the creation of some of mankind's most famous monuments.
Just a few million years after the first stars formed, some of them exploded. Wham!
These explosions, known as supernovas, are the biggest blasts in the universe since the Big Bang, providing the extra boost of energy needed to fuse heavier elements. In the fiery blast of their own destruction, stars create uranium, gold, all the rest of the elements that will fill our world, including copper.
We have iron in our blood. We have
Copper and tin, Bronze Age. Without supernovas, there's no Bronze Age. Go to any supermarket and buy a multivitamin. And go and look in the ingredients. You'll find copper, you'll find zinc, you'll find selenium, you'll find all sorts of elements that can only be made in a supernova.
To build a proper house, you have to assemble the right materials all in one place.
Now, when planets form, it's the same thing. It's the materials that you have at hand that's going to dictate the kind of house that your planet's going to be.
To get enough of the right material in the right place, all at once, takes a very long time. Over the next 8 billion years, more than half of history as we know it, the element factories continue their work. Stars explode and are reborn. Each generation with more heavy elements than the last. until 4.6 billion years ago. Finally, there are enough materials gathered for the next step on the path to us. A new star is born. This is our sun. It's so massive that it's gathered up 99.9% of the gas and dust in the solar system. But there's still just enough left behind for gravity to build some other things, like planets. The third one out from this star will be our home. By the time Earth emerges, just over 4.5 billion years ago, 2/3 of the history of the universe has already passed. The first sunrises sweep across a foreboding alien planet. A world spinning so rapidly that a day lasts only 6 hours.
When you go back to the early Earth, right after the planet formed, you really have to think of the Earth as another planet. The sun would have looked out over a hellacious scene of just molten lava. In places, you would see rafts of black volcanic rock.
Lighter material drifts toward the surface and forms a solid crust, while heavier material sinks toward the center, forming a molten iron-nickel core. This churning liquid metal creates a magnetic field that reaches out into space. Like a force field, it will protect our future home from the sun's deadly charged particles. Soon, this magnetic field will allow for life to grow, and later guide the explorers who will connect two halves of the world. 4.5 billion years ago, an object the size of Mars smashes into the planet at 25,000 miles per hour. Earth swallows up much of the impactor. But a spray of molten debris is whipped off into space. Within as little as a year, gravity gathers this debris into a secondary sphere in orbit around the Earth, where it has been ever since.
The formation of the moon was an incredibly important event in Earth's history.
And in fact, its creation over 4 billion years ago is really important to the Earth's climate today.
The moon keeps Earth steady. Its gravitational pull prevents the planet from wobbling, saving us from wild climate swings. And the collision that formed the moon leaves Earth tilted on its axis, giving the planet a key ingredient to life: seasons.
Having seasons is very, very important for the evolution of life on the Earth. And having some stability in the tilt of those axes, that's very, very important also for maintaining life on the Earth.
The moon's gravity also begins to slow Earth's rotation, which will eventually lengthen our days from 6 hours to 24. 4.4 billion years ago. It's too hot on Earth for liquid water to exist, but there's water vapor, steam in the atmosphere. The trick is how to get it out of the sky onto any world where you hope to have life. A little rain must fall. For millions of years, as the planet cools, rain pours down, forming puddles, lakes, and eventually our oceans. 3.8 billion years ago, beneath the surface of our primeval oceans, a revolution is taking place. 6 simple elements including hydrogen from the Big Bang, and oxygen, carbon, and nitrogen created by stars, have combined to form the key substances that will make up all life, including us. The most spectacular is DNA. Within its spirals hide the secret codes of life. 700,000 years after the planet first formed, life on Earth begins. We stand not on the shoulders of giants, but of tiny organisms, bacteria. 2.5 billion years ago, some very special bacteria figure out how to consume the sun's energy to live. In doing this, they also create the most important waste product in the history of the world: oxygen. Earth's ancient seas are full of iron particles, and everyone knows what happens when oxygen meets iron.
Here I'm a little bacterium. I've produced this oxygen molecule, and here's a big piece of iron clump. I rust it.
This rusted iron collects on the seafloor. Billions of years later, these huge deposits will be raised up to become major sources of the world's iron and steel.
It was these iron deposits that later on drove the industrial.
Once there's no more iron left in the sea to rust, these ancient bacteria have a mission to complete. They create so much oxygen that it fills the oceans and escapes into the atmosphere.
And from then on, we have a very different planet from all the other planets in the solar
Over the
system.
next 2 billion years, life becomes more complex. Skies become blue, and so do the oceans that reflect them. Large, solid continents appear. Earth is beginning to look more like the place we now call home. With oxygen comes an ozone layer, protecting us from dangerous radiation. Plants make the move first. Around 400 million years ago, animals are ready to take the leap. Among the first ashore are the amphibians. 300 million years ago, life flourishes in massive tropical swamps, where planet Earth is cooking up a surprise. As plants die here, they are buried, compacted, and cooked. Is now locked away underground as coal, a gift to be opened by human beings millions of years in the future. Dinosaurs will reign for the next 160 million years. During that time, the first hardwood forests appear. And after more than 4 billion years, the moon's gravity finally settles Earth into a 24-hour day. At the start of the dinosaur era, the continents are clustered together into a single landmass we call Pangaea. But now, they start to break apart. Africa separates from South America. The vast Atlantic Ocean opens up. "65 million years ago, a 6-mile-wide object, likely an asteroid, slams into the Earth. A dust cloud blocks out the sun. Temperatures plummet. Every creature on land weighing over 50 pounds goes extinct. The reign of the dinosaurs is over. As the continents drift, the Americas and Africa have almost fully taken shape. But in northern Africa, modern-day Egypt is submerged beneath an ancient sea. On the floor of that sea live small shelled creatures called nummulites. Their shells, made of calcium and carbon, pile up on the sea bottom over millions of years, where they form into limestone. Limestone that will be used to build the Great Pyramids. If you look closely at the pyramids today, you can still see evidence that these 4,000-year-old monuments are, in fact, made of 50-million-year-old seashells. By 10 million years ago, Earth is morphing into a world most of us would recognize. The Colorado River is carving out the Grand Canyon. Mountain ranges like the Himalayas have arisen. They're so tall, they disrupt weather patterns, setting the stage for a colder planet.